In this section, we're going to talk about energy and power, and this is probably the area that we are least familiar with throughout this chapter. And for that reason, it's important to take it very slowly. You might have to repeat the video a couple of times and just be very cautious with your homework. Well, energy is the ability to do work, and a unit used in measuring energy is the foot-pound. 1 foot-pound of energy is the amount of energy required to lift 1 pound a distance of 1 foot. Hence the clever notation foot-pound, you see. 1 pound, 1 foot. If we were talking about the amount of energy required to lift, let's say 5 pounds, a distance of 10 feet, 5 times 10, that would be 50. You see, foot-pounds of energy would be required. All right, another unit that is used to measure energy is the British Thermal Unit, or BTU. Now, air conditioners and furnaces are often carry a BTU rating for energy. 1 BTU is 778 foot-pounds. Now, this then is a conversion factor. We can go from BTUs to foot-pounds to BTUs if we'd like to do that. Let's have a look at a problem. Suppose we want to convert 250 BTUs to foot-pounds. Well, it's handled in much the same way that conversions were handled in the past. All we need to do is refer to our relationship between foot-pounds and BTUs. That's all there is to it. So we begin the same way that we did before. We're talking about 250 BTU, and we think of this as 250 BTUs times a fraction which has BTUs in the denominator and the item we're converting to in the numerator. So we want foot-pounds up here. It's foot times pound, you see, for foot-pound. All right, now, what about the conversion? Well, we look back over at the conversion and we see, 1 BTU is 778 foot-pounds. So 778, and now we have the expected cancellation, and now it's a matter of multiplying 250 times 778, and we attach the unit foot-pounds. And this becomes, let's see, I have it written at the bottom of the board. I can't do this in my head. It's 194,500 foot-pounds. Here's another one. Find the energy required for a 125-pound person to climb a mile-high mountain. Now, we're not talking about BTUs here. We're just talking about basic energy, which is foot-pounds. Now, the problem could go on and say, gee, how much BTU does this correspond with? Well, we don't have that in this problem. But I want you to know that when you face a problem in this area of energy and power, as we'll see in a moment, then try to separate the units. Understand what unit that we're talking about. It doesn't request anything about BTU here, so we're just talking about the basic energy unit of foot-pound. All right, now, and that's the idea of feet times pounds, and that's all there is to it. So the person is 125 pounds, and the person is climbing a mile high. So it's the equivalent of lifting 125 pounds 1 mile up. Now, 1 mile, gee, what is that in terms of feet? Because we need feet and pounds here, you see. Well, a mile is 5,280. So it's a matter of taking 125 pounds and multiplying times 5,280 feet. And when these are multiplied, we get 660,000, and the unit is pounds times feet, feet times pound, foot-pound. So it's, so it's foot-pounds, 660,000 foot-pounds of energy. A furnace is rated at 80,000 BTUs per hour. That's the output of a particular furnace. How many foot-pounds of energy are released in 1 hour? wow, it's going to be a huge amount, because every BTU, remember, was 778, let me make sure, I'll look back over here, so you might need to look it up too, 778 foot-pounds, you see, for every BTU. So it's a huge number. But here's how it goes. We're just converting then 80,000 BTUs into foot-pounds. So it's 80,000 BTUs that we think of as 80,000 BTUs times a fraction with BTUs in the denominator and foot-pounds in the numerator. And 1 BTU was 778 foot-pounds, so the BTUs cancel, and we have 778 times 80,000, huge number. Down at the bottom of the board, I'm reading it as 62,240,000 foot-pounds. Let's talk about power. Power is defined as the rate at which work is done. The rate. Now, when we talk about a rate like for an automobile, like, let's see, miles per hour, something like that. Well, this is kind of a rate at which work is done. So it is something per time. Oh, it's energy per time. It's foot-pounds per second, you see. Foot-pounds per second. Now notice the notation, foot-pounds per second. Now if in making a calculation about this, it sounds complicated, but it's really easy. 100 pounds is lifted 10 feet in 10 seconds. How do we make this calculation? Do we need a formula? No, we just kind of refer to this foot-pounds per second idea to make the calculation for our unit in dealing with power. So foot-pounds per second, so we're going to multiply feet times pounds and divide by seconds. That's what that implies. So the power here is, let's see, the feet times the pounds divided by the seconds. You see, 10 feet, 100 pounds, 10 seconds. We get a cancellation here, and we get 100 for the numerical part. But the interesting thing is the unit part. It's foot-pounds per second. So foot-pounds per second over here for the power. Now, the foot-pound per second is a unit, but in the U.S. customary system of measure, 1 horsepower is a unit for power. And 1 horsepower is 550 foot-pounds per second. Now, this is just a conversion. It's just a conversion that we're going to use, similar to the idea of BTU and foot-pounds, you see. It is horsepower compared to foot-pounds per second. It is a measure of, or a unit dealing with power. A motor has a power of 2,750 foot-pounds per second. Find the horsepower of this motor. Well, it's just a matter of conversion. Let's come back over here and make the conversion. We are converting some number of foot-pounds per second into some number for horsepower. Well, let's see. We take this 2,750 foot-pounds per second and we're going to multiply it. I'm not going to repeat this over here because I'm going to run out of room, but we're going to multiply this times a fraction, which is, well, let's see, we've got this conversion of horsepower and foot-pounds per second, and it's like we want foot-pounds per second here in the denominator in order to accomplish the cancellation, and we want horsepower up here. Our horsepower up there. All right, let's see. Now, what's the conversion idea? Well, we look at what we wrote over here. 1 horsepower is 550 foot-pounds per second. Now this gives us an idea of what we need to do. These cancel, and we think of this as being over 1, so we're dividing 550 into 2750. And it turns out that it goes 5 times. So, and in fact, it'll cancel if I divide 550 into 550 goes 1 time. 550 into 2750 goes 5 times. And what I have here, when the smoke clears on all of the cancellation opportunities, I have 5 horsepower. So 5 horsepower is the power rating on this motor.